How you doing, physics fans? Today we're going to talk about electric fields. Now, electric fields are found in chapter 5.4 of volume 2 of your textbook. And electric fields are pretty interesting things. It's the first time we've ever talked about fields, so let's talk about fields first. So field, whenever you have a field, there's certain types in physics we talk about. You're going to talk about magnetic fields, you're going to talk about electric fields in this course. There's also gravitational fields. So a field is, all we're saying is when some object has a physical property associated with it, in this case a electric charge. If we have electric charge, that object is going to have something that happens all around it, in the space all around that object. In this case we say it's an electric field. So let's talk about what those are and then what objects with charge in this electric field are going to do. So the electric field, we use the symbol E, and what it is, it's a property of the space around a charged particle. Since it's a vector, we have both a magnitude and a direction. So let's talk about the magnitude first. The magnitude is on your PRC, and we can also see it's here. It's 1 over 4 pi times the permittivity of free space times the charge of the particle divided by r squared, which is the distance from that charged particle that you're looking for. You will also see Coulomb's constant, or this K constant. All you need to know is that's a constant of a constant. They're interchangeable. So we give you this quantity K, and we also give you permittivity of free space. So you can calculate both, and you'll see it there. They end up being the same quantity. This is equal right here. So you can substitute those in. Now the direction, when we talk about direction, this points away from positive charge and it points towards negative charge, as you can see here. So for a point particle, my electric field points away in all directions. For a negative particle, I can see that my electric field points towards in all directions. Now again, the equation we give you is only applicable for a point charge. That's all we're talking about. A point that has a charge associated with it. Now, let's talk about force and electric field. So I said before that one object that has this physical quantity, in this case charge, has this property everywhere around it. Now, when I place other objects, in this case we'll take another test charge, and I place that in the electric field, it is going to feel a force. So the force that it feels is given by this equation right here. So the force is equal to the charge of the object I place in the field times the electric field at that point. So let's take an example. So let's say I place a charge right here. I can solve for the electric field at this point in space. I'll use this charge, plug that quantity in there, solve for the magnitude of my electric field, and then I know that this positive charge will now feel a force. So since it's positive, I know that it's going to go in the same direction as the electric field lines, so it's going to be attracted to this point right here. And that's consistent with what it's saying here. So I know I will feel a force going in this direction. Now, let's try it with the positive charge. I come over here, I place the positive charge right here. Now the positive charge next to an electric field that's pointing away is going to be repelled. When I go back and look at my force equation, I see that that's also consistent, that it's going to be the same direction of the field lines and it's going to be repelled. So let's look at that one more time. I place a positive charge here. I know my force is going to want to go this way because of this equation, or because I know that opposites attract. Likewise, when I go to place this positive test charge towards another positive charge, I place it in the field and I see it's going to be repelled in this case, or going in the same direction as the electric field lines. That concludes this video on electric fields, and we'll see you next time.